Hello, I'm Chris Athenis. I'm a KMP developer. I need to fix that camera. Tech support's coming out Tuesday for this bad boy to shut that thing down eventually, hopefully this time. Today I'm going to be reacting to my favorite backend, kind of like a big picture kind of guy. He's not the technical details guy I would go to for individual implementation details. But for overall, like, what the heck are we doing on this with back end stuff? How to like think about back end stuff? Derek Co-Martin of Code Opinion. He's the guy. So give him a like and subscribe. But I'm gonna react to this video.
Hey, it's Derek Martin from CodeOpinion.com. There's a lot of challenges with event-driven architecture and messaging, and not all of them come with a good solution. There's a lot of benefits, but the trade-off is often complexity. I think one of the primary issues, which is getting better, but it's still one of the primary issues, is visibility, especially if you're using messaging and event-driven architecture for workflows. For example, let's say we have a client, place an order, that sends a command to our broker. We have sales, then picks up that message and consumes it. Let's say it places the order, then it publishes an event to some topic within that broker, and then from there we have some type of workflow kicking off, where we have some type of billing, boundary service, it consumes that event, then it says, okay, I'm gonna reply back to that saying, yes, the order was billed, we have some type of workflow going here. So sales picks that up and says, okay, we're changing our state now. Order's been placed, it's been billed. Now we're gonna let shipping know that it has to get its part of the bargain here and create a shipping label. So shipping gets that message, it picks it up. It has to send a reply so that sales knows at this point, okay, our entire workflow is complete. How do we possibly?
Okay, so this right here is this the back end that we're talking about. This is the client on for KMP projects for KMP micro monopolies. This is your client is going to be your Android app, your iOS app, your web app, your desktop app, whatever, however you want to deploy that thing. Console if you want to. And this all inside here is your back end, right? And you're using a message queue like Redis or something like that, or just internally keeping a database of the messages coming in and write them into a table in your database, and just keeping track of things that way. That could be done that way as well. It doesn't have to be Redis. Redis just works super well and is scalable, and it'll keep your it's battle hardened and all that stuff. So these are your not your little, but these are your different services here that are all running inside one container. Usually for these micro monopoly applications, you just have to have one running container. You're gonna have less than 100,000 customers, so it's gonna be fine. So yeah, that's what he's talking about here.
Gets that message, it picks it up, it has to send a reply so that sales knows at this point, okay, our entire workflow is complete. How do we possibly get any visibility into that workflow?
Right. Yeah. So having multiple microservices, each one of those little boxes, those services being separate processes running on separate computers, yeah, it gets super hairy. You do need to know how to look at that stuff. And even if it's just on one machine, on a modular monolith, yeah, you still want to know where everything's going, how it's what messages are where, what the state of the thing. You do want to know that.
Before I get into a solution, I'd like to thank EventStore for sponsoring this video. EventStore DB is a new category of operational database built for event sourcing, CQRS, and event-driven microservices. For more on EventStore DB, check out the link in the description. And this is actually a simple example. In the real world, you'd be publishing an event, having multiple consumers, kicking off different workflows, different kind of paths. Yeah. How do you get visibility into that? So when something started, what was the actual finish line here? Like, when was the actual workflow finished? How do I get any insight into all these different services that are passing messages around? Ideally, I just want to be able to see a timeline of everything happening. Client A publishes a message. Service A consumes that. Maybe it does something else that now Service B consumes. Service C was consuming the same message from Service A. It kicked something off that Service D picked up. I just want to be able to see kind of a timeline. OpenTelemetry fills this need, and you might be familiar with it.
So he does stuff in C#, but it's very similar to KTOR and Kotlin, but you can just think of these as a sketch. We're not going to do our stuff in C#, but this is just kind of a sketch to give you the idea of what we're talking about. And he's talking about the dark side, some of the things that can go wrong, and the issues that you kind of have to think about when you're building these systems, so you don't go crazy when they start going wrong or doing things you don't expect.
Capturing things like HTTP requests, database calls, but it's also great for asynchronous work. And when you're publishing a message, who's consuming it, etc. So I have an example here where it's exactly the first kind of diagram that I showed, where I have essentially 3 projects involved in a workflow, and it gets kicked off from this ASP.NET Core web application. To illustrate this, I'm using nService Bus. I'm configuring it to use OpenTelemetry. I'm also using Zipkin. I'll show that in a second. But I'm just going to set a bunch of different breakpoints and run through this so you can see everything that happens. So the first thing,
there's different libraries for C#. We on Kotlin, we're going to use different libraries, but that does the same stuff.
That happened is I'm placing my order, and I sent that command within Service Bus, and it's receiving it. Next thing that actually happens here is that now that we've actually placed our order, we're consuming the order place event and using an nService Bus Saga, we're now going to be sending the command to bill the order. I'm going to receive that on our billing side, which is a completely separate process. It's going to reply to that saying the order was billed. We're back into our Saga. From there, we decided, hey, we got to send a create shipping label to the shipping system, so we can then, at this point, contact FedEx, for example. This actually takes a little bit of time. And once it finished, We now have our shipping label created, and this completes our saga. But if I didn't just debug all this and have everything running, how would I actually visually see all this happening? But because I had OpenTelemetry configured and capturing all those traces within service bus
So Zipkin is just one of these tools to look into your processes, see how things are working. Cool.
and exporting them to Zipkin, I can actually see this entire trace. So I can see that there were 3 services involved. There was 17 total spans. You can actually look, as I was kind of illustrating before, at the entire process that occurred. Everything along the way. What message was consumed, by what happened from there. You can see the entire stack trace, essentially, across services. So I mentioned not every problem has a good solution. This is a good solution to the problem of visibility. So what's the problem? Cost, the monetary cost. In my experience, this can be really high if you have a high volume of workflows, events, and messages in your production system, and you want to capture all of it. Let's say you have order 1, 2, 3, there's an issue in production. You're like, okay, great. I'm just going to go in Zipkin or whatever I'm capturing it with, look for that particular order. I'll see everything that happened. The problem is if you have a lot of volume, you may not want to capture everything and just be sampling. And if you do that, you might not be able to find that trace for that particular order. However, if you're just using it for development purposes, locally, for debugging purposes, it can actually be a really great tool.
Yeah,
just be aware in
sure.
production, depending on your volume, it may not be feasible.
Yeah, that's a good point. These services, they're trying to make money. Come on.
Love to know in the comments if you're using OpenTelemetry, what your experience has been. Are you self-hosting? Are you using
So KTOR, it has telemetry stuff. I don't know if it's that sophisticated level, but it has that kind of stuff.
in cloud services? What about the cost? Let me know in the comments. Another major issue is consistency. For example, we have a client make a request.
This is always an issue. Always an issue. And we we think that by doing these modular, like monoliths, that we're going to just don't have to worry about this consistency issue. Eventually it's going to come up. So might as well think about it ahead of time.
To our app service, we make some type of state change to our database because some action was performed, and then we publish an event to notify other consumers that that action actually happened. Great, because then other consumers pick up their workflows like I mentioned before. The problem is, we've all probably experienced this, is there's some bug in code where now data is maybe incorrect in our database. So we as developers analyze, figure out what the actual issue is, and then we just go manually update the data to fix it to what it actually should be. We fixed our code going forward, but we still have to manually fix data. If we touched our database, or it could be some other client app that's connecting directly to that database, we're bypassing that API that ultimately is responsible for publishing that event. So one solution would be you'd have to understand the code, understand what event should have gotten published, and maybe you have some way of just constructing that event and publishing it manually. That can work. Still not an easy thing to do, but it's something, a road that you might go down. You may decide to think, okay, well, we're using Debezium or some type of CDC, change data capture tool, and it can do that, sure, but you kind of oftentimes lose the intent of what actually happened, so you'll be deriving potentially what actually happened to other consumers. I also find if you're using a CDC tool, you're generally using it for data.
CDC is control, command data capture, or change data capture. So instead of trying to look at all the different endpoints coming into the database, you're just looking at the trail of the change log. That's all that is.
Propagation and not for workflow. So they're kind of two different concerns there. The third solution is you don't actually record current state, therefore meaning that you wouldn't actually be able to go update data. Oftentimes, if you're using something like event sourcing, you'd be actually looking at the events because it's an append-only stream. You're looking at your events and deriving from that things that you're actually going to publish.
Yeah, so the event sourcing stuff is probably the best thing I've seen. That eventually, if you're going to do bigger scale, like, if you're going to go more than 100,000 customers, probably, you're going to think about doing an event sourcing type of system, which is basically just you're keeping track of every single change. There's no actual database stored anywhere. It's just the events rolling in, and you keep track of them, maybe in the database someplace, but you're just rolling. They're all the rolling changes. So anything that would be done in that system to change it would have to be a compensating change, right?
So there's different ways of dealing with this. However, it's not just kind of clear cut what you're going to do. You can't just go bypass your API. Another major hurdle is thinking about if you process the same message more than once, will it cause havoc in your system? Will multiple workflows get kicked off for the exact same thing? What kind of issues will that cause? So it's thinking about you want your system to be idempotent and thinking about it being essentially reentrant. And it's something you're constantly having to think about. So for example, again, I'm generalizing this, thinking about there's different ways message brokers work. So if we have a publisher publish a message to our broker, let's say we have a consumer where it gets just a single message at a time. There's different ways of doing this. Ultimately, what it's going to do is consume that message, and there's generally a timeout, a length of time that's needed before the consumer says, okay, I've acknowledged that I've actually processed this message. That'll either, on a queue-based broker, remove it, or it'll change the offset of where that message is, where you are, that consumer group. But you're still doing this kind of, okay, I'm done working with it. So there's a variety of reasons why you could end up processing the exact same message, but to use my illustration of not acknowledging in time because of a timeout, we're processing that message, it's taking too long, we don't acknowledge.
So these consumers are the services that are being kicked off by whatever these messages are being sent by the publisher. The publisher could be your client, like your iOS app, your Android app, your web app, whatever, or it could be another one of these services that I'm done with this part of the work. Please go somebody else do the next part of it. And there's that's why they have a publisher who's like emitting the events and consumers who are accepting the events. And these consumers and publishers could be all the same. They could be publishing and consuming. How you set your system up.
knowledge in time, that means that that message is now visible to other consumers within our group, and it ends up receiving it so it can process the exact same message. Now, there's often times where consuming the same message more than once is totally fine, and that's kind of naturally idempotent, where you process the exact same message and there's really no negative side effects. Or there's times where you process that same message, let's say billing an order, and you do it more than once. Well, you build the order more than once, it probably doesn't have a good outcome. There are a couple different solutions to this. The first is per consumer, just actually record what messages you've already processed. So having some type of storage where you're storing, okay, here's some type of message identifier of the messages I processed, and doing a lookup to see if you have already. To deal with concurrency, if you're making your state changes.
Yeah, so you might have have to have another table database that keeps track of the orders already processed. Okay, well, not that bad. Like, just gotta think about it.
Recording in that same database with the message IDs that you've processed, if you're doing that all within the same transaction, you can at least deal with concurrency in that form. And another way with dealing with concurrency is just don't, meaning that you only have a single instance of that consumer processing messages one at a time. And if you're using something like just recording that ID, you don't have the issues of concurrency. The trade-off there is throughput. We'll get to that next now. And what can bring your system to its knees is latency, whether it be a queue or if it's a topic because it's events, and consumer lag. So you're producing messages to your broker, you have your consumers consuming them, but you're simply producing more messages quicker than you can actually consume, and you can never really catch up. Ultimately, your inflow.
I also call this back pressure. Okay, it just makes sense. Like, there's too many customers coming. Oh my god, I'm swamped.
Rate is greater than your outflow of how many messages you can process. A solution to this is just to scale out, to add more instances so you can process more messages concurrently so you can keep up. The downside to this,
yeah, so you have to add a load balancer, and then it'll do what's called reverse proxy, right? Where our messages come in, instead of going directly and then being processed here, it's being split between 3 or 4 or 5 or 10 or however many you want to scale up to, different instances that are processing that particular message. Okay.
Is, as I was showing earlier, is that if you have concurrency issues where you need to process a message one at a time, that means that you only have a single instance, so you can't use the competing consumers pattern. As you can see, there's a lot of trade-offs and a lot of complexities, and I hope this video illustrated that. It's just not all roses of event-driven architecture and messaging. There's kind of a lot of stumbling blocks that you'll kind of find along the way, and hopefully I illustrated some. Let me know.
Yeah, I mean, but it's better than the MVP, like the single modular, everything's stuck in with everything else. Everything's concurrently done working. If that works for an MVP, you can get away with that for an MVP. But once you want to scale up a little bit more than 1,000 people, one of the companies I worked at, they could get to about 5,000 before having to do an event-driven system like this. They got to about 5,000 customers, and they just start going to a grinding halt. So if you can think about it ahead of time and maybe design your modular monolith in this way, using these kinds of event-driven architectures, when it comes time to split off that piece, it can become a service and work without having much modification because it's already in the event system. All right, go give him a like and subscribe. I'll put his link in the diddly do down there, and give me a like and subscribe. And I'll talk to you soon. Bye.